What happens if you have a cable behind a wall or buried in the ground and it breaks? How do you know where to dig or where to take out drywall? That's what we're going to find out right now, and then we'll draw today's test gear winners. Since we're live today, we'll also take some Q&A from the chat at the end of the stream. But first, let's jump right into our test gear tip of the day.
Hi, I'm Sarah. Today we're going to find a fault in a cable using Keysight's FieldFox handheld analyzer. There are two important measurements for finding out the length of a cable, verifying cable performance, and determining if failures or discontinuities exist in your transmission line. Both of these measurements are useful in cases where you can't visually inspect the entirety of your cable because it's extremely long, like cables on an airplane or a cruise ship. The first is a distance to fault or DTF measurement. A DTF measurement performs a line sweep and it displays the return loss in decibels versus distance. In layman's terms, it injects a frequency sweep into the cable and then reads back how much power gets lost along that cable. It also tells you the length of your cable, given that you know or you can calculate the velocity factor of the cable. For this measurement, I have an 8-meter long cable, and it's attached to a 0.6 meter long cable with an adapter and a short on the end. I've centered the display around the largest reflection point, which represents the end of the transmission line. You can see here that a marker on the peak gives me a total distance reading of 8.57 meters. When we measure it with the tape measure, we get the same value. Trust me, I had to measure it earlier. Close enough. Measuring it physically was also a lot of work and a little annoying. But in many cases, it's not possible because the cable is buried in a wall or it's in the ground. Now we've run out the cable and we suspect there's a fault somewhere. Let's find it. These two larger bumps on the screen represent the reflection of the signal at the connection point between the two cables. Looking at this display, I notice there's a reflection reading here that's a little concerning to me. It looks like there's a fault near the end of my transmission line. So, I'm going to switch to a time domain reflectometry or TDR measurement to get a little more information about this fault. Because the signal increases, we know that this fault is inductive, which can be useful when determining what is wrong with the cable and how to approach the problem. So I'll place a marker near the fault. We can see here that it's located around 8.6 meters down the cable. Let's go see if we can figure out what the problem is. We're just going to walk the length of the cable instead of measuring because my measuring tape maxes out at 5 feet and I don't want to go through that again.
So that brings us to the first and hopefully last episode of the Noise Doyle Hunter. We're gonna go out into the wild and look for some crazy noise.
You're on my cable.
Who's the accent? I'm a professional voice actor. And besides, all of the big electronics YouTubers have distinct accents.
That was awkward thanks to Daniel, but I was able to figure out that my cable had a fault. I was able to locate it and understand the nature of the problem using DTF and TDR measurements, and then replace it with a good cable. And now the TDR measurement doesn't show a fault at all. If this were an underground cable, we'd know right where to dig to fix it. To find out more about time domain measurements using FieldFox handheld analyzers, read the app note Techniques for Time Domain Measurements linked below. Thanks for watching.
And the app note that Sarah mentioned is available on the Wave website. That's wavekeysight.com, and it's in the Field Test Handhelds resource library. We have 12 different library collections we've handpicked for you. If you haven't gone over there yet, it's packed with what I consider to be essential reading. If you like these tips, we also do videos year-round, not just during Wave, so make sure to subscribe and hit the bell to get updates, because you never quite know what the YouTube algorithm is going to do. You know, they might do something funky with your recommended videos. Anyways, let's take a quick look at the Wave webpage on my laptop here. So if you go to wavekeysight.com, you'll get, and you sign up, you'll get to this page. You can get your daily entry by clicking this button, but we also have our library. So if you look at these tabs, you kind of basically scroll down through here, click, I've pre-opened them just to make it a little smoother. You can see on the FieldFox library here, we have that app note Sarah talked about, so make sure to click over there and check it out. And like I said, there are 12 of them, so go check out them. They are essentially essential reading in my book. This is also the second week of Wave 2020, so if you're just joining us, we have 5 other days of video tips and winner drawings. Sarah had another great tip on Monday, which looked at how a microwave impacts Wi-Fi speed. And on Friday, we took a FieldFox and tested a breadboard's performance. And there's a bunch more. It's not just FieldFox stuff, so go check them out after this video's over. You can also sign up for the test gear giveaway at wavekeysight.com. You get 1 extra entry per day by hitting that button between now and Friday after your first registration, which is also an entry. And all of your entries are included in every day's drawing. Each day between now and Thursday, you can win one of 5 of these U1282A handheld DMMs. So let's roll the tape with all of the prizes that you can win. So each day, 5 are 4-channel awesome scopes. I need to be able to see that. Also, you can win one of U1282 handheld every day, and 1 Tier 2 prize winner each day between now and Thursday. The first one of those is a 3000 T series oscilloscope. That's a look at this tip coming with that on Wednesday also. There's handheld rather than winner each day. Also a hertz stack. We have a that we and on Friday, it sounds like we're having some audio issues there, so we're just going to cut that tape. On Friday, we are picking a prize winner who wins a Tier 2 prize or a Tier 1 prize on Friday, and they get their choice of a scope like this. You could win a FieldFox handheld analyzer. You can win a USB network analyzer. There are all kinds of great prizes you could win. So again, each day you could win one of 5 of these DMMs, one of 5 of these scopes, and we're picking 1 person who can win a bigger prize. So make sure to tune in here every day between now and then to see if you've won. Also, we'll draw today's winner in a moment, but first we have a bonus test gear tip that Aaron put together for last year, which explores how to use your oscilloscope's trigger hold-off.
By default, oscilloscope triggers have a certain rearm time. So what this means is your oscilloscope triggers, and then it rearms to trigger again and find the next occurrence of your signal event. This rearm time is usually pretty fast to ensure that you aren't missing any events in your signal. And in most cases, this is exactly how we want the oscilloscope to function. However, there are of course some special cases where we want that trigger to wait a little bit longer to rearm. Let's look at this packet of pulses as an example. This entire packet is about 250 microseconds wide. Plus I can see there's a little glitch on the end here that I also want to capture. So let's say the entire packet is about 350 microseconds wide. Well, that packet width is far longer than the trigger rearm time. So you can see as I'm triggering on this signal, we're seeing some flickering going on here. This is because the oscilloscope is triggering on that first pulse in the packet, rearming, and then incorrectly triggering again on another pulse in that same packet. Whereas we would ideally want it to trigger on this packet, wait, and then trigger on the next packet. It should not be triggering on anything aside from the first pulse in the packet. So we basically want to tell the oscilloscope to wait for the entire packet to be captured and then rearm the trigger. If you go into the trigger menu, you can set a hold off time. So like I said, we want the oscilloscope to wait until the entire packet has been captured for the trigger to rearm, which means we want to set the hold off equivalent to the width of the packet, 350 microseconds. You can see now that the trigger is actually stable and we can clearly see the packet on screen. Now you can make accurate measurements on it and perform analysis.
Thanks, Aaron, for that tip. If you want to learn more test gear best practices, make sure to check out the Wave libraries. There's just so much good stuff over there. You'd be crazy to not go poking around. And now it's time to draw today's winners. And right after that is Q&A, so put your questions in the chat now. I have it pulled up over here, so I'll be able to take your questions as they roll in. Today's winners of the 1000X, that's the DSO-X1204G, are Anil Ozalson, Drew Pikula, Lucas Krobach, Piers DeBasto, and Ian Simpson. Congratulations to those winners. The winners of the U1282A handheld DMM. I saw some comments in chat about it, actually. I have one at home. I use it all the time, and in the lab here. Those winners are Brett Gable, Marco Moda, Ian McKenzie, Charles Gray, and David Mackey. Congratulations to those winners. And the winner of the Tier 2 prize, they'll get their choice of a scope or all those other prizes we looked at earlier. I know the audio is glitching, so thanks for bearing with us while we're live. The winner of that is Ko Chan. So congrats to our winners. We'll be sending you an email shortly. 66 people so far have won gear, and we've seen some of you in the comments and over on Twitter, so shout out to all of you who are watching and have won. And there are 44 more prizes to go this week, so make sure to tune in for the rest of the week to see if you've won. And that ends the formal live stream. We'll also be back daily for the next 4 days, including our closing live stream on Friday at 10 a.m. Mountain Time. Thanks for watching. Make sure you subscribe to this channel, and let's dive right into the Q&A. The first thing, we have this 6000X series oscilloscope that we're giving away on Friday. So one of the things I love about this scope is that it has color grading, and I really enjoy the color grading capabilities on this guy. You can do that with FFTs and all kinds of fun stuff. So I'm gonna pull up chat now, and let's see what, so someone said, oh, I won. Oh, no, just kidding. You actually got me. Okay. Someone asked what the minimum THD you can measure with a 3000T FFT match function is. I don't actually know that question, but we did cover THD in a video earlier using a signal analyzer. And that THD is traditionally measured with RF gear, but you can do it with a 3000T. I'd have to go dig into the data sheet and see what the specs are on that. And I'm gonna pull up, some of you put in questions in chat earlier on during the stream, and I know I took some of those as well. So let's see. That's a good question. How to make strip-line splitters to make a 50 ohm antenna system. That's really something, one of the things you can do with antennas is you can just pull footprints for your PCB and slap them on. But if you want to go test them, you're actually going to need a VNA. So one of the fun things we got some comments on these rulers, and I'll actually, I'm going to pull it up for the close-up camera here. This is what we use for some of the tip videos for like drawing and stuff as a straight edge, but we have these rulers. I'll actually give a couple away. I'm not going to draw the winners live or on camera. But I'll give a couple of these away. I know we got some questions throughout the week about these. So we have an RF one and a digital one. And it has, why I popped that up is I wanted to show that there are some antenna filters here. So we can pop back up to the close-up here. There's actually some example antennas for different technologies and different lengths, like quarter wavelength, half wavelength type things. And these are just footprints that you can download for your favorite systems. So if you use KiCad or Altium or whatever you're doing, just pull in your Bluetooth footprint or your Wi-Fi footprint, have space on your board. But if you want to go test it, you might have to do some OTA testing, you might have to do some cable and testing to make sure it actually performs the way you expect. But in a pinch, you can kind of throw the footprint on and just hope it works. But of course, we recommend testing it. Can the oscilloscope read resistance? So that's a good question. So oscilloscopes don't really have a resistance measurement capability like a DMM does. But one of the things you can do is use, if you have a function generator in your scope, so the 6000X has a function generator, pretty much all the Infinivision scopes have a function generator option. You can run a known voltage or current across the resistor and see essentially current like a shunt resistor and measure resistance that way, do the math. But I think most people have a handheld DMM around. If you don't have a DMM and you have a scope, that would be, you'd be a winner in my book. But you should also get a handheld DMM. What else? Do I like Electroboom? He's great. I actually interviewed him for the podcast recently. So if the Double E's Talk Tech podcast, eestalktech.com, you can go check that out, or wherever you get your podcasts. There's an interview with Electroboom. I hadn't really seen or found many English interviews with him, so it was a great chance to sit down and chat. We were in New York City for something together, and I got to snag some time with him, so go check that out. How do you make sure the scope will fit the exact job required? So basically, how do you make sure you get the right scope and a scope that's usable for you? The most common spec is bandwidth. So if you essentially want to look at the fastest signal you need to measure, and you want to get a couple times that bandwidth. So if you have a 100 megahertz clock, for example, you'd probably want a 200 or 300 megahertz scope to measure that. We did a video on bandwidth. Actually, the live stream on Monday talked through how to measure bandwidth. If not, there's a video on our channel I put together a year or two back about what bandwidth is and how to pick that out and how to make sure it's right. So if you just search our channel for bandwidth, you'll find that video. What else? Someone asked, what about EEV blog? Yeah, Dave is great also. The thing I love about Dave is he just tells it like it is all the time, and he has so much knowledge that whenever anything pops up, he just almost always knows how to handle it just off the cuff, which I learned so much watching that channel. Someone wants to know where they can get the mug. You can come on the podcast, I'll give you a mug. Let's see, what else? Someone asked earlier in chat, right before the stream started, do we have any scopes that run on battery power? And we do have an old 6000, not a 6000X, but like the generation before this, we have a battery powered option. Most people don't actually, they might think they need it, but they don't actually. The times that I've seen people want to use a battery scope is for testing like automotive systems where they're out in the field. We really recommend just getting an aftermarket battery pack and running battery that way. There's a lot of, it's tricky to get a battery powered scope working the way you want it to, all the time. And batteries are notoriously, tricky to use. So using an aftermarket pack is what we recommend. What other questions do we have? You can keep putting questions in. I lost my chat window here. Let's see. Can the scope be controlled through a PC like using LabVIEW? Yes, so all of the Infinivision scopes, most of the bench gear, I think every prize option has a BenchView remote access. You can also use Skippy commands, and BenchView is now included complementary with every, even the handheld power supplies scopes. You get BenchView with that model or products app for BenchView for free, included with it. So if you already have Keysight gear, go check it out. I think you just have to type in the model or serial number, and you'll get access to all the BenchView stuff. BenchView's fantastic. Infinite persistence is the best thing since sliced bread. Yeah, if you ever used analog scopes, persistence wasn't really a thing. We also have that intensity knob, which we talked about on Monday. So, it's people, there's a lot of debate online, less now than there used to be a couple years ago, about analog scopes versus digital scopes. But digital scopes just have so much more to offer than analog scopes. They're fun to play around with, but if you're doing real design work, you really want a digital scope. When to use by one by one probes or by 10 probes. So the probes we're using on here, if we go to the close-up, I'm gonna kill my signal here. There's a little switch on the front here. You can switch between 1x and 10x. The difference between the two of those, 1x mode, you lose a lot of bandwidth and you get, I think, higher loading. 10x, but your noise is lower when you're in 1x mode. So you're loading your system more, your bandwidth is not as good, but your noise is better. The 10x probes are really nice because you're not loading your scope or you're not loading your system as much. And we talked a little bit about probe loading on Monday as well, but essentially there's an inductive and capacitance load, mostly capacitive load, when you hook up test equipment to your designs. So being able to reduce that is the reason a lot of people, especially on higher end systems, buy fancy probes to go with, to test their system, because you don't want to break your oscillator or mess up your transmission lines or communication lines when you go to probe it. So we recommend using 1X, especially for measuring things like power rails, that sort of thing. Which reminds me, I saw a comment come in earlier about measuring DC power rails, DC power with probes. There are DC power rail probes. I think it's like the N7020A. If you search Keysight.com for power rail probe, we also have a couple webcasts. There's a webcast from I think 2017 that's still one of the better performing videos on this channel that looks at how to measure power rails. And the problem is when you have a DC offset, you still want to zoom in on that signal, but you can't necessarily move it to center screen and zoom in because you're going to start breaking the dynamic range of the scope, and then you get kind of weird behavior. So you can use a power rail probe with an automatic DC offset, and that lets you get right in on that without using AC coupling, without using a DC blocker. And that's really the way to go if you're trying to measure power integrity on your power rails. So what other questions do we have? What about Great Scott? I want to do an interview with Great Scott. I haven't reached out to him yet, but that's a good suggestion. We should get him on the podcast as well. I know the Amp Hour did an interview with him. That was maybe a year or two ago. So if you want to hear that, you can go check out the Amp Hour podcast. That's with Dave Jones from the EEV blog and Chris Gammo from Contextual Electronics, and he does some contracting work and that sort of thing. Can the oscilloscope decode signals like serial or I2C? Yes. So the 1000Xs, as of I think like 2 weeks ago, they actually come with protocol decoding included for free in the base price of the scope. So there's a new 2-channel model, which we'll maybe talk about later in the week, and the 4-channel model now come with protocol decoding included. I don't think we had any tips on that today, but we just did a whole series with Melissa about decoding different protocols. So go check our recent videos and you'll see a bunch of protocol decoding examples there. You can do them on the 6000, 4000, 3000, 2000, or the 1000X series scopes, and they're pretty awesome. Decoding, it's all done in hardware, and you can get a lister and trigger on errors, that sort of thing. Decoding, I would never want to decode a serial bus without one of these again. Coming from college, I was basically like decoding the ones and zeros on a scope to an actual built-in decoder. It's just night and day difference between the two. Someone mentioned the signal path is also good. Yeah, we've worked with him a little bit. He did a teardown of the UXR, which is our 110 gigahertz scope. So he does such a good job doing high-tech, high-quality teardowns. I highly recommend you go check out the signal path on YouTube. It's not one of the bigger channels, but boy does he deep dive into test gear like no one else does on the internet. So I recommend checking those out. Let's see. No USB-based oscilloscopes are in the giveaway today. We do have a USB scope. It looks just like that VNA. I don't know if we saw that clip or not because we're having the audio lag. But we do have a USB option. It runs on the same processing chip as the other scopes. It just runs in BenchView, using that same interface. So highly recommend that. If you need USB, it's much smaller, has no screen. You have to use it with a computer, but it's great. Someone says, can I do an interview with Electric Boom? We did. You must be new here. Check out earlier in the stream. Also on the Keysight podcast YouTube channel, there's a video there, or eestalktech.com is where that is. That's, the mug is also, from the podcast. So we'll take a couple more questions and then we'll wrap it up. Let's see. Benchtop multimeter versus a handheld multimeter. That would be a great standalone video. I'm going to add that to my list of videos that we should create. The nice thing about a handheld DMM is it's super portable. You're not tied to mains, but what you don't get is you don't get the resolution that you get on a benchtop DMM. And often the accuracy is not quite there as well. But the same teams are designing the handhelds and the benchtops, so you still get pretty good performance for whatever class of DMM it's in. I told my video guy I wasn't going to do a close-up on the DMM, but here we go anyway. So there's a ton of capabilities. You still can do a ton of different measurements on a DMM. That's why they call it a multimeter. The same is true of benchtop, but this is a 4.5 digit handheld DMM, and that's about as high of a resolution as you get on a DMM for a handheld option. The benchtop ones, they go up to, I'm gonna go grab it real quick, stay on the close-up. The benchtop ones go up to 7.5 digits. So if you have something like I'm gonna just scoot the scope over. If you have something like a 7.5 digit, you're able to get a lot higher resolution with something like this compared to a handheld DMM. So that's really where it comes down to it. One of the interesting things we see people do with especially the higher digit DMMs is they'll get this calibrated and then they'll calibrate all their other meters that are lower digits. So they're 6.5, 5.5, 4.5, based on the calibration of the 7.5 digit, because you have enough extra headroom to get the measurements you need on those DMMs. So that's a good question. We should do a video on that one. I'll add that to the list. Let's see. Should I plug the scope into a UPS or an uninterruptible power supply in order to get clean power? That's a great question. Your mains power quality can impact your measurements. The ground of your scope is tied to earth ground, but we do a lot to make sure that the actual power converter from AC to DC in the scope gets a really clean DC output. It goes back to measuring power rails and measuring your power integrity. If you have ripple on your power rails, you're gonna have noise in your system. So we do a lot to clean those signals up and clean that power up as it comes in. But you know, the power that you plug into does make a difference. So if you have bad, rough mains, I know some countries have more, less harmonics, higher quality wall power. Then if you're in a country that doesn't have great wall power or power from the grid, then it's worth checking out a UPS. The other thing we did, I think it was 2 years ago, is we have an AC power analyzer. If you search our channel for AC power analyzer, we did a tip with Bill, who we're bringing back for Wednesday, and he's been on a couple other tips and videos with us. An AC power analyzer to actually measure the quality of the power coming out of the wall. So recommend checking that video out as well. Here's a question about DACs. So we have the DAC 973A is the new DAC we just came out with. The question is, what is the practical difference between acquiring data with a microcontroller or with a DAC? So there's a whole list of items, differences. I'm not gonna go into those completely, but I've seen some like Raspberry Pi data loggers, or some Arduino data loggers, that sort of thing, versus an actual DAC. The thing that a DAC does is the sample rate is very, very high and very, very consistent. With a microcontroller, it's not always as reliable and your sample rate's gonna be lower. Also with a DAC, you can get things like multiplexer modules. So one of the things that you saw in that prize clip from earlier in the video is those modules that slide in the back. You can get all kinds of, the flexibility with the DAC is it's very flexible compared to something like a Raspberry Pi. So that's the main difference. Okay, 1 or 2 more questions and then we're gonna call it for the day. We'll also be back live on Friday, and you can put comments, if you're watching not live, you can put comments down below. I read all those comments, so we'll take questions there as well. Let's see, what about measuring L and C? Is Keysight an expert in that as well? I actually have a handheld meter, so let's go to close up and I'm gonna grab my LC meter real quick. So I just got this like last week, and I'm pretty excited about it since someone asked about it. I even still have the clear plastic on, so you get to witness. This is my favorite part of getting new test gear, is ripping off the screen cover. There's just nothing quite like that feeling. So we do a bunch of inductance and capacitance measurements. Something like this, the U1733C is a great option for that. And it comes in this fancy case and you get all kinds of accessories. But using something like this to measure L and C, inductance and capacitance, is the way to go. I also did a video recently meaning like a year or 2 ago, about how to measure the time constant with an oscilloscope. So if you just Google how to measure the time constant with an oscilloscope, you'll find that video is a good one. It's one of our more popular videos on this channel as well. So good question. And I think that's probably about where we want to call it for today. Someone asked about software to analyze exported CSV waveforms. MATLAB is kind of an industry standard for that. You can also do some Python analysis if there's some nice libraries out there for analyzing data. But we're gonna call it for the day, so thank you so much for watching and tuning in and getting to this point in the live stream. If you have questions, like I said, you can put them in chat. I'm Daniel Bogdanoff. Make sure to subscribe to this channel, and I will see you back right on this channel tomorrow at 10 a.m.